This is our second demonstration video for our project. Just to be clear, the content of this presentation was a collaborative effort between all the group members. We just felt it'd be easier if I just recorded the voiceover, but again, everyone contributed, and we actually have footage coming in from other people in the group as well that I will be talking over. So please don't let the fact that it's only my voice alarm you. Everyone's helping. So, in case you forget a bit what Humidibot's all about, we're just going to go over a quick recap so you don't have to look up the first demonstration video again. So the problem we're aiming to solve is that the room that you're living in needs to be as healthy of an environment as possible. And typically people don't have ways to either measure the humidity in a room, or if they do have a way to measure the humidity, they have no idea what they're aiming for or what they can do to change it so that it's at a more ideal level. Humidibot is a web app that streamlines that whole process, the process of figuring out what temperature and humidity you're going to aim for and then implementing that. So humidity is a culprit in a plant's health and ultimate lifespan, and being able to read and manipulate it should be as simple as possible for everyone. So Humidibot allows the user to set up multiple rooms, keep track of readings in their house or even in their greenhouse. We have the ability to specify parameters for each room to determine the optimal temperature and humidity for that room. We do have residence mode and greenhouse mode, so both types of users can get the most out of Humidibot, and it's all going to be cloud-based. Once you have our hardware, you connect it to the cloud, and we essentially do the rest. Of course, users can modify some other settings to, make it more towards their specifications, but any user can go in and just set up a room in residence mode, and they already have recommendations going in. So what are the current features of Humidibot? We have the ability to read temperature and humidity data in real time with our hardware and update the database with the latest readings. I'll show that off later in this presentation. We have that working. That was a big problem with our first demo, but we've gotten that covered. Of course, we have our dashboard UI. You can see all of your rooms, and you can expound upon them, and I'll go over what expounded means in this case. Of course, we have the login UI. You can register an account. You can recover a password. That's very standard stuff. You'll have the ability to add, delete, and change rooms and have multiple different devices registered to the same account, all of them sending readings to the database and updating in fairly real time. Of course, there's a little bit of a delay, but that's just nature. We also have the ability to set some parameters for a room, like doors being open or closed, windows being open or closed. Is there a fan in the room? Do you have a humidifier or a dehumidifier in the room? You'll be able to set all of that from the web app. And of course, we have our algorithm layer, which gets expanded upon in this next slide. So how does our algorithm layer work? It'll suggest the course of action for a user's room determined by their active parameters. So closing a window would be a great way, I'm sure you'd agree, to increase the temperature of your room, in most cases anyway. But if there is no window in your room, let's just say it's a bathroom you have Humidibot set up in, or perhaps the window is closed already, wouldn't make sense to suggest to close the window. So it'll move on to the next best thing, which is close the door. So there might be situations where nothing that's actually in the room can help. If that's the case, which will be rare, we do have recommendations to perhaps purchase equipment to help that. So a humidifier to raise the humidity of a dry room, for instance. And the exact temperatures and humidities that are too high or too low are determined by the people and plants in each room, and settings that are set in either residence mode or greenhouse mode. So we're going to go into more detail about how this part works right now. So right here we have a nice little table that we use to make our algorithm for determining temperature and humidity. So for now, we have the target temperature from 60 to 77 degrees Fahrenheit, and our desired relative humidity range is 60 to 90% for plants and 50 to 60% for humans. That's just for the purposes of this table as placeholder values. And the way we calculate these values, I'll go over right after this. So here we have the case that temperature and humidity are too low. So we have a sequence of parameters that will suggest what the user should do. And here we just have placeholder text. It's going to be grammatically slightly different in the final product. But here, if the temperature and humidity are too low, for instance, we have, first of all, they should close the window, close any doors, turn off any fans, turn off the dehumidifier, turn on a humidifier if they have it, and add a heat source. Now, these recommendations are roughly in order of effectiveness and feasibility. So anything that's both feasible and effective will be listed first. And then it'll go down the list. So adding a heat source often isn't very feasible, so that's why it's low on the parameter sequence. And we have sequences for all possible cases. Now here's the pseudocode for how this is working, put in this format for ease of understanding. So as you can see, if the temperature and humidity are both too low, we have a little variable called params. That's just which parameter in this list is going to be recommended for the user. And then we have message equals, and then we have a reference to parameters. So it'll say, hi, insert username here. We notice your temperature and humidity for, and then the name of the room, is too low. You should. And then whatever the desired parameter is. So for instance, let's say the window is closed already. So this one would not be a recommendation that makes any sense. You're not going to close a window that's already closed. So we'll say close the door. Don't let any excess cold in. Don't let any heat leave, in other words. And similar code is abound for all the other cases. Now, if you notice, we have a temp max and humid max variable, and then we also have a temp min and humid min variable as well. How are those determined? So if we scroll down here, we can see the pseudocode for the function that finds the threshold values. So we have, it just takes a simple weighted average, and this will change depending on your settings, but every plant and human that's living in a room, as added by the user, will have their own associated minimum temperature threshold value and their maximum temperature threshold value. So if we have a plant, for instance, that likes low humidity and high temperature, like for instance the cactus, it'll have a range. There'll be a range of about 15 to 20 degrees depending on how picky the plant is, but these live in nature, so they can survive some variance. A range of a minimum temperature to a maximum temperature that's pretty high. For a cactus that normally lives in the desert, it would be pretty sky high. And then for humidity, we have a range of, depending on the type, Could be anywhere from 10 to 30% relative humidity level that's acceptable. And this algorithm just takes all of the minimum temperature values for every plant, averages them, and those for every human and averages them. And then with 0.25 weight for the plants and 0.75 weight for the humans, it'll determine a weighted average ideal minimum temperature. But this is only for residence mode. So an average resident might have, 2 people and a little plant on their windowsill. That's the sort of mode that residence mode would equate to. But if you have greenhouse mode activated, you'll actually be able to set the weights manually, and usually the plants will matter more because humans typically aren't going to be living in a greenhouse. They're going to be, checking in on it from time to time. So plants will be weighed a lot more if the user so desires. They'll be able to set it with a slider. Again, it just calculates a weighted average of all the plants' thresholds and all the humans' thresholds for all 4 parameter values: the minimum temperature and humidity and the maximum temperature and humidity. And as you can see, the code for the rest of this is nearly identical, so we're not going to waste time going over that. Okay guys, so what I'm about to play for you is a video of Gregory just using the web app and viewing the readings from Alex's device. Now that sounds confusing. I'll explain it, why we did it this way shortly. But as you can see, he's going to sign in with his own Gmail account and submit. And right here, here's the dashboard. It's in residence mode at the moment. If you notice, we have a little box where you can input an SSID. But down here, we have 2 rooms. One has 35% relative humidity and a temperature of 72.4 degrees. The other one has 42.7% humidity and a temperature of 74.84 degrees. So now if you click on the details of one room, if you notice the room doesn't have a title. So the title of each room is tied to the account. So Gregory right now doesn't have a name for room 1 on his account. So he's just going to call it test room 1. He's going to say, hey, this has no door and there's no dehumidifier in the room, but there is a window and a fan and a humidifier. So here, you're just going to type in the SSID SoftEng. So the device associated with the SSID SoftEng is actually the one that Alex has been working with. And if you want, you can go to the actual web app and type in that SSID under your own account, and you'll be able to see readings from those devices on your account. So the reason we did it this way is because we know you guys aren't going to have the hardware available to you. Obviously, the final product wouldn't have things working like this. It would just be, you would link up the devices to your account initially, and then that'll persist with your account. But not everyone has those devices. So if you want to try it out yourself, using that SSID is the only way to do that. But yeah, so here if you click on the details for room 1, you could see that even though he refreshed the page, these persist as you would expect from a competent web app. It doesn't make you input the parameters every single time. Now here on the second test room, he decides to name it test room 2. And this room has no door and a closed window and no fan, but it does have a humidifier and a dehumidifier. What an odd room. However, this is an option you have to input. And here are the updated humidity and temperature readings. You can see if you look very closely at Room 2, it is changing live as Gregory was recording this. So those are the parameters for test 1, in case you're skeptical. And then those are the parameters for test 2. As you can see, they're consistent. So, and of course, you could sign out, and then it'll bring you back to the login page where you can register for another account. So in case you're curious about how everything is looking inside the database, you can see a little flashing going on. That's because we have live update. So if we go into SSIDs, which are associated with the actual devices, and then we go to software engineering, the one we typed in earlier, we can see that this device is updating constantly with humidity and temperature readings. Right now, it seems the temperature is staying pretty constant, but the humidity is changing. Now, you also notice a flashing from the user tree, and we're going to track down the source of that flashing right now. It seems it's coming from the second room, and indeed, under that user account, there's a room, and it's called room 2, and the humidity is indeed changing to reflect, the device with this SSID. So we're not going to, of course, go into too much detail about, the JavaScript behind it, but that's basically what's going on behind the scenes.